So next is residues. Okay. So we have to find what is residue integration. So before that we have to find what is a residue. So let Z naught is an isolated singularity of f of z. So f of z is Z naught is an isolated singularity. So we can expand f of z as the Laurent series expansion, that is sigma a n into z minus z naught all raised to n plus sigma b n by z minus z naught all raised to n. So this is the Laurent series expansion, this is the Taylor series part, and this is the principal part. What is the principal part? Z minus z naught, the powers of z minus z naught containing in the denominator. So that those terms are called a principal part. Okay. Then what is the residue? Okay, so we are discussing about the residue. So what is the residue? It is the coefficient of 1 by z minus z naught, or 1 by z, or 1 by z minus z naught. So the coefficient of 1 by z minus z naught is the in this term, in the principal part, what is the coefficient of 1 by z minus z naught? That is called the residue of f of z at z is equal to z naught. Okay. To solve a problem, we have to use another method. If z is equal to z naught is a pole of order 1. Order 1 means it is a simple pole. Okay. That is repeating only one time. Z is equal to z naught is a pole or singularity which is repeating only one time. So residue at z is equal to z naught at f of z is equal to limit z tends to z naught, z minus z naught into f of z. So multiply the function with z minus z naught so that the denominator get cancelled. Okay. And put the value z limit z tends to z naught. And if we get more than one time, z is equal to z naught m times repeating singularity. So for m times repeating singularity, we can say that it is a pole of order m. Okay, so z naught is a repeated singularity. Then how will you find the residue? So there is a in the formula there is a small modification. Residue at z is equal to z naught f of z is 1 by m minus 1 factorial. M times repeating singularity is z naught. So subtract 1 from m. So it is m minus 1. M minus 1 factorial. M എത്രയാണോ അതിൽ നിന്ന് ഒന്ന് കുറയ്ക്കുക. അപ്പോൾ ആ ഒന്ന് കുറച്ച നമ്പറാണ് നമ്മൾ ഈ സൈഡിൽ എല്ലായിടത്തും ഓപ്പറേറ്റ് ചെയ്യുന്നത്. സോ 1 by m minus 1 factorial into limit z tends to z naught d raised to m minus 1 by dz raised to m minus 1. That is, we have to find the m minus 1th derivative. If it is of order 2, we have to find the first derivative. If it is of order 3, we have to find the second derivative, etc. So what is the order? You subtract 1 from that order, then find the derivative derivative. Okay, so d raised to m minus 1 by dz raised to m minus 1 of what? Z minus z naught all raised to m into f of z. Here z minus z naught into f of z. So here z minus z naught all raised to m into f of z. Here also we get the factor in the denominator z minus z naught all raised to m, because m times repeating singularity is this one. So this denominator gets cancelled. Okay. So only the function f of z. We need to find the derivative of f of z in effect. Okay. So that's the formula to find the residue. It's a particular case. If z is equal to z naught is a pole of order 2, then residue is limit z tends to z naught d by dz. Here repeating 2 times. So 1 by 1 factorial is there, because 1 factorial is 1, 2 minus 1 is 1. So 1 by 1 factorial. 1 factorial is 1. So we need only write this term, limit z tends to z naught, then derivative 1 time, 2 minus 1, 1 time, d by dz of z minus z the whole square into f of z. And if it is of order 3, then residue at z is equal to z naught f of z is 1 by order 3. So subtracting 1 from 3, 3 minus 1, it is 2. So 1 by 2 factorial into ഒന്ന് കുറച്ച് എഴുതുക, limit z tends to z naught, then 2 time അല്ലേ, but second derivative d square by dz square z minus z naught the whole square into f of z. Okay, sorry, ഇവിടെ z minus z naught the whole cube, 3 times repeating root അല്ലേ. Okay,